In this video, we're going to solve systems of equations using Gauss-Jordan. So the big idea here, this is another method for solving the same thing we were doing in the last problems. So Gauss-Jordan uses matrices. So what is a matrix? Well, it is simple. It's just a rectangular arrangement of numbers. So literally, we're just going to take numbers, no variables. We're going to just write them in a rectangle. Now, it's common for each row of your rectangle to represent an equation, each column to represent the coefficients of a specific variable. So think of each column representing a unique variable, x, then y, then z, so on and so forth. And always solve your solutions so the equal sign is on the right-hand side, followed by the constant term. All right, so not in words. What does that mean, like in actual practice? Let's write this as a matrix. Okay. So the top equation will be my top row, and I'm going to write just the coefficients, 3, -4, 12. The bottom row, what is the coefficient on the x? 1. The coefficient on the y? 6. The coefficient on the z, or the equal sign? 5. Now, for the reader to know that these aren't all variables, x, y, z, for them to know that there's an equal sign, we put a little bar here, and that's what makes it called an augmented matrix. Excuse me. The other key thing is you must have these brackets. If you don't have the brackets, I don't know where one matrix starts and the next one ends. You must put the brackets. Okay, now for the columns. You don't have to write anything, but just so you can kind of keep track, you'll notice this is my variables for x, right? 3x, 1x, 3x, 1x, right? The next one is y, -4y, 6y, right? And so on and so forth. So the idea here is it just takes two equations and writes them a little neater, puts them in a way where we could deal with 17 equations and just put them in a nice little rectangle, much easier to look at. Now, what we're doing, Gauss-Jordan, how is it related to the elimination technique? It's exactly the elimination technique. It is the same, okay? We're not learning anything new. We're just using elimination technique in a rectangle. Okay, so the rules for Gauss-Jordan are the same as the rules for elimination. What are you allowed to do to your rows? You can multiply any row by a non-zero scalar, aka a number. Multiply any row by any number as long as it's not zero, right? So when you're doing Gauss-Jordan, when you're doing elimination and you're trying to get your numbers to be the opposite of each other, so 6 and -6, you would multiply your equation. All right, so you have to multiply the whole row. Second, once you have your values that match, the 6 and -6, for example, you then add the rows together. Now, technically, you're allowed to subtract, but we're not going to do that in here. So you're only allowed to add the two rows. Now, the thing that makes it a little different is we're going to replace one of the two rows with the new row that you just created. It's more of like a bookkeeping thing than is anything, because if you kept adding on new rows for every time you added two together, your matrix would get huge. So this way we just kind of replace one of the ones we already had. There's a class called linear algebra where you'd learn why that's okay and why you're not actually losing anything, but just take my word for it, you're allowed to do it. Last but not least, you're allowed to swap row positions, meaning if instead of writing the 3, -4, 12 on the top, you wanted to write it on the bottom, that's fine, right? It's completely arbitrary to which one's on top, which one's on bottom. The other fun thing you can do is you can also swap your columns, right? There's no reason x has to come first. That's just, we wrote it that way because it's alphabetical order, right? So you absolutely could write it this way if you wanted to. You just have to remember now that your y's are first, your x's are second, and then your equal signs are the 12 and the 5. Note, you can't move those. Those must stay on the right. Okay, that's it. There's not a big deal. So now, what do we do with Gauss-Jordan? Well, our goal is we're going to use elimination technique to get ones in the top left corner, and then we're going to get ones in the diagonal going down, and zeros everywhere else. Now, of course, the equal sign is still the equal sign. We're not going to mess with that. So you can see here in this next one that's a little bigger, same idea. One in the top left corner, ones down the diagonal, zeros everywhere else. Now, why is this nice? Well, let's just assume this is an x and a y. Read the top equation. It's just telling you 1x plus 0y's equals 4. Or aka x equals 4. And then the second equation is y equals -2. So do you see your answer just kind of pops out when it looks like this? So if you had 7 variables, it would still be easy to read. Well, this one only has 3, so x, y, and z, but it'd still be easy to read. X equals 2, y equals -3, z equals 4. So that's why we like Gauss-Jordan. And it doesn't have to be exactly like this. You can have all sorts of things. That's why I have or dot dot dot. And we'll get to some of those other unique cases later. But for now, just hopefully gives you an idea. So I know that's the theory. So now in the next video, we're going to do it. And I'm going to walk you through the notation. I'm going to show you how to do all this. So we'll see you in the next video.